Good morning to all. Now this lecture class is in continuation with the previous topics. In the previous session, we discussed classification of signals, that means continuous time signal and discrete time signal. Now this class is in continuation with the previous one. Here in this class we are going to discuss various kinds of signals. Let us start. Let us start. Now, various types or kinds of signals. Now here we are going to discuss various kinds of signals. Now, the first one we are going to discuss with a rectangular signal. For example, what is a rectangular signal? This is a rectangular signal. For example, just look at this is t, this is x of t. Amplitude 1 and 2. Now just look at this is a rectangular signal. The width is here, the width of the signal, that is 1, 4 width. This is, for example, A, amplitude. Amplitude equal to A. This is the width of the signal. For this one, how to give a modeling or mathematical notation of rectangular signal. This is called modeling or mathematical representation of rectangular signal. For this one, the graph x of t is equal to amplitude multiplied by, it is based upon which one? Independent variable t by width. That is, for example, look at amplitude equal to 2. That means how here in this case, how can we write a rectangular one? Amplitude, that is 2 times 2 by, what is the width? 1 to 4, 4 units, that is equal to 4. That is equal to, it is the mathematical description of rectangular signal. Rectangular signal, the mathematical description. Now, next one, you go for ramp signal. This is a ramp signal. Here one more point. In most of the cases, some authors may write like this. Come back. In rectangular signal, some authors may write like this. Just look at, this is t, this is x of t, amplitude. This is amplitude, this is A amplitude. Here from t, period t to minus t. Some others give the description like this. Here clear cut, for understanding purpose, I used numerical values. The actual width of the signal is given here, but here they will be given in terms of t only. In this case, how to give the model? That means x of t is equal to amplitude into the variable, independent variable t by the total width equal to 2t. It will be like this. The total width will be 2t. Some others will write like this. Now, ramp signal. The ramp signal is just like this, t and x of t. Now, it passes, this is ramp signal. Ramp signal is a practical applications of the staircases or ramp slopes on making our bikes courses to go down. For all these purposes, it is using. Very important real life practical example. Now, ramp function. How to give a mathematical representation to this one? Now, it is the ramp function generally denoted by ramp r of t. This is ramp r of t. Just intermediate this graph represents y equal to mx. Intermediate, paper 1A, 1B. Here m is called what? Slope. X is the independent variable, y is dependent variable. Now ramp function. How to get the ramp function? The ramp function is equal, look at, from 0 to, it ranges like this. This is ramp function. From this here it is 0. Therefore, the ramp function representation equal to 0 when t is less than or equal to 0, but equal to t when t is greater than 0. Now look at the mathematical representation of ramp signal. The ramp signal from up to 0 for all the values, it is 0. For 0 it is 0, but whenever 0 is increasing on the positive axis, correspondingly linearly it is also increasing like this. That is called ramp signal. This is the mathematical representation of ramp signal. Here in intermediate maths we use a straight line that passes through the origin y equal to mx. Now in signal systems we use a ramp signal that equal to some amplitude into t. For example, this is some amplitude A. We call it as slope or height, whatever it may be. This is the representation of ramp signal. Now next one. The next one is called parabolic signal. Parabolic signal. Just look at, this is one. In intermediate, this is the parabolic representation of the graph x, this is y. Parabolic representation, x square is equal to 4ay graph. From that we are going to get parabolic signal in signal systems. But here there was a full curve is used. Here we are not using full curve. Parabolic signal means what? Now just look at, take a parallel axis t and parabolic signal. This is x of t. This is the origin 0. Now just look at, this is a parabolic signal. How to give? Now this curve ranges. This curve ranges from origin onwards. Before origin, the curve, no curve appears here. Therefore, the parabolic curve mathematical representation that can be written as 0 when t is less than or equal to 0. But it is t square by 2 when t is greater than 0. T square by 2 is greater than when t is greater than 0. This thing we have to observe. Up to this it is 0, but it ranges here like this only. As the value on t is increases, the curve ranges like this only. This curve is not a straight line. That is, look at, it is a 45 degrees straight line here. This is a curve, half of the curve, therefore t square by 2. This is which one? Parabolic signal. Next one, sinusoidal signal. Next one, sinusoidal signal. Sinusoidal signal means what? Sine curve. The sine curve. Sine curve always passes through the origin like this. This is t. This is sine t. Graph of sine t. Just look at. One of the fundamental importance of sine curve is that it always passes through the origin. Very important one. Here, just look at this height of this curve. This is called amplitude A. In the bottom side, it will be minus A. Minus A. That is the amplitude, because the periodic representation of sin x always belongs to which one? -1 to 1 only. So based upon that one, students have to remember how to draw a sinusoidal. Actually, in mathematics, we call it as sine curve, cos curve. But in electronics and electrical, we call it as sinusoidal curve. Sinusoidal curve. Here, students may have one doubt. we are discussing only sine curve, but not discussing cosine curve. Why? No need to worry. The same graph, just we have to make it like this. It will become a cosine curve. Cosine curve, because why? Here the amplitude is equal to what? 1. Now just look at this, is called 0. Now the difference between cosine and sine curve is that the sine sinusoidal curve passes to the origin, but cos curve passes through 1 only. One more point, sine 90 minus theta, that is equal to cos theta. You know intermediate first year trigonometry, cos theta. That means what? What is the phase difference? Here the angle pi by 2. In electronics we call that as phase difference. Only phase difference 90 degrees. So from the sinusoidal curve, by making the 90 degrees phase difference, we are going to get the next curve, cosine curve. So the actual curve is sinusoidal. From that we can get cosine curve. So cosine curve no need to be used here. In all the cases we use sine. That sine means what? Sinusoidal curves we use here in this one. So these are different types of signals: rectangular signal, ramp signal, parabolic signal, sinusoidal signal. Here one more signal is there, that is called triangular signal. That is called triangular signal. Triangular signal. For example, just look at this is a signal, triangular signal, amplitude A. This is for example T or minus T. How to give a mathematical representation to this triangular curve? For this is x of t. Here this is t. Now it is written in A, T and minus T only. How to give mathematical representation? In this case, here x of t is equal to amplitude. Amplitude means this one, amplitude into 1 minus the independent variable t by t. Look at t by t. In examination they ask you, for example, look at, they will give one curve. Look at, this is 3, here minus 4, this is 4. Now give mathematical representation to this triangular curve. They will give the graph. Students have to find out mathematical notation. So in this case you have to find that x of t, that is equal to amplitude. Amplitude means how much? Here 3. 3 times 1 minus independent variable t by 4 only. This is the mathematical representation of triangular signal. Now compare with rectangular signal. In rectangular signal, what we discussed? In rectangular signal, what we discussed? For example, look at, this is the one, t, this is x of t, this is minus t, this is t, this is amplitude A. This is amplitude A. In this case, how to give mathematical representation of this one? In this one, the rectangular function is x of t equal to amplitude times t times 2t. For example, look at, they give like this. This is t, this is x of t, a rectangular signal, minus 4 to 4, amplitude equal to 3. The sketch they will give. Now here students have to give a mathematical representation. That means for this purpose we have to make x of t is equal to amplitude how much? 3. 3 times independent variable t by, here t means how much? 4. 2 4s 8. That means what? 3t by 8. That is the rectangular representation. The difference between triangular signal and rectangular signals. So this the end of this one. Thank you.